Bismillahirrahmanirrahim. This is our 15th lecture of Mechanics 2. Here we will see the topic of uh, torque and electric force or cross product. We have to consider coordinate system, and here this is our origin, and this axis is representing the x-axis, this axis is y-axis, and this axis is z. Let with reference to our region, we are having a point P at which is being located by the position vector R, and at this point P an external force or net force acts in this way, and this force is making an angle theta with the position vector R. Then ultimately, under the influence of this applied force, a rotational effect will be produced on this particle, and this turning effect is marked as tau, which is equal to cross product of two vectors. One is the position vector, other is the applied force vector, and this tau will be uh, along the direction, along the axis, which will be perpendicular on the plane of these two vectors. One is the r vector, other is the f vector. When we join these two vectors, uh, equal vector of r will be lying here, and when we will rotate the fingers of right hand into the second vector, then the thumb will be pointed in the direction of the axis, and this direction will be the direction of torque, which is vector quantity, and this torque is perpendicular to the plane of these two vectors, r vector and f vector. So we consider a force F acting on a particle P, which is positioned by this vector R with respect to our origin, and the magnitude of torque, this torque, which is the cross product of these two vectors, it can be said that it is having magnitude Rx sine theta. This is the magnitude of this cross product, where theta is angle between two vectors, r vector and the force vector. We can see here that due to this applied force, the rotational effect will be about z-axis. Hence, we can say that the turning effect will be along z-axis, and that axis is perpendicular to the plane formed by these two vectors, r vector and f vector. In a standard way, we can express this turning effect by this Greek letter tau, and this arrowhead is representing its vector nature, and we can say vector is equal to r cross s. This is our equation number 1, and here we can see that how the turning effect is being expressed by vector product of two vectors. One is the position vector of the point P on which this external force F is being applied. Now we are familiar with the cross product and dot product of vectors. Here uh, we will discuss the cross product or vector product of any two vectors. Uh, if we are having two vectors, one is A vector, the other is B vector, and they are at an angle theta with respect to each other, then we can say that their vector product will be equal to a C vector, which is a third vector, and this C vector can be said as the resultant vector of this cross product. So this C vector will be possessing a magnitude as well as direction. Its magnitude can be expressed by the magnitudes of these two vectors A and B, and sine of angle between these two vectors. So what will be the direction of this vector? As we have earlier said that the cross product is always perpendicular to the plane of the two vectors. If these two vectors are lying in xy plane, then C will compulsorily be lying along z axis. So this vector will be perpendicular to the plane of these two vectors. If uh, the magnitude of this resulting vector is AB sine theta, then we can say that this is the magnitude as if it is the area of a parallelogram, and this parallelogram is being formed by these two vectors A and B. Means one side of the parallelogram is A and the other side is B vector, and the direction of this C will be perpendicular to the plane of the parallelogram. Some of the characteristics of cross product are mentioned here. As we know that A and B are making an angle theta with each other, so we can say that cross product or vector product of these two vectors A and B is not commutative. Means we cannot say that A plus B is equal to B plus A, but it is equal to minus B plus A. So we say that cross product or vector product is not commutative. If angle between the two vectors A and B is 0 degree or 180 degree, then cross product will be a null vector. If the angle between these two vectors A and B is equal to 90 degrees, then the magnitude of this cross product will be equal to AB sine theta, as sine 90 degree will be equal to 1. So we can say that this magnitude is equal to product of magnitudes of two vectors A and B. If there are three vectors A cross B cross C in this order, we can write this left hand side of the expression as this right hand side of the equation. A cross B plus A cross B. This this equation is indicating that cross product holds distributive law. If we take time derivative of the cross product of two vectors, then we can express this time derivative of two vectors as uh, time derivative of first vector cross second vector plus first vector cross time derivative of second vector. For unit vectors, we take cross product always equals I cross I will always be equal to j cross j will always be equal to c cross k, and this will be equal to 0. Null vector means as I and I two vectors will be having an angle of 0 degree between them. So this angle of 0 degree will be the main cause to give the result of cross product as null vector. Similarly, I cross j can be said to be equal to minus j cross I, and this can be equated to unit vector k. J cross k can be written as minus j cross j, and this cross product will be along this unit vector I. K cross I will be equal to minus I cross k, and this will be equal to j unit vector. And if we are having two vectors, then we can exchange the sign of these two vectors in cross product. As you can see here, I cross minus j is equal to minus I cross j. The cross product of two vectors A and B can be found with the help of well-known determinant method. Here we express the I, j, and k unit vectors for all the three rectangular components of the two vectors involved. Here we will be expressing As, here Ay, here Ab. These are the rectangular components of the first vector A vector, and similarly the rectangular components of the second vector will be Bx, By, and Bz. So A cross B will be taken as Ay Bz minus Az By into unit vector I plus plus Ax Bz. Here it will be minus Ax Bz minus Az Bx into j, but minus will be taken from, and here we will get plus sign, and the order of the two terms will be changed with the bracket. And here we will see plus ax by minus ay dx into k minus vector. So this expression is representing the cross product of two vectors which are having the rectangular components along the three axes: x-axis, y-axis, and z. Thank you.